My intention is after watching this video, you make the Waves Tune real time your default vocal tuning plugin. Just stick around to the end and let me convince you. Let's go. Hello guys, fellow audio engineers, you're welcome to the video. Today I'm going to use the analogy of a compressor to show you how to use the Waves Tune real time to its fullest. Yes, you got me right. We are going to use the analogy of a compressor and apply the same concept into the Waves Tune real time, and you would understand this plugin to its totality once and for all. If you could just stick right to the end, I promise you by the end of the video, you would approach the plugin with a different perspective and a brand new confidence like never before. Before we get to it, guys, let me play you a snippet of the vocals we would use in this video to demonstrate how this works. Please show some love, hit the like button, drop a comment, and don't forget to subscribe. Let's get to it already.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar from January to December. I need you on my antenna. My antenna.
So guys, when you load up the Waves Tune real time, on default the interface looks like this. But then before I go right into tuning, there's this first thing I always do, which is to check out the key and the scale of the song. And the way I do that is I use a key detector plugin. And we're going to be using the auto key tool from Antares. And something worth mentioning, guys, Waves actually has a key detector plugin that communicates with the Waves Tune real time. That being said, guys, let's check out the key and the scale of our song. You see, it quickly tells us that our instrumental is in the key of C major. And guys, I like the fact that it's actually on C major because now we know we are working with only white notes. This information is very crucial and is going to come in somewhere down the line in the video to help you guys further understand certain controls on the Waves Tune real time plugin. So these are the default settings, guys. We already have our key and our scale. Let's go right away and set that up. And we're doing it right down here at the bottom of the plugin. Our key is C and we are on a major scale. Let's hear how the vocal sounds by just setting up the key and the scale.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar.
The next thing I always do, guys, after setting up the key and the scale of the song is I stay right down here at the bottom and set up the range of the vocal. The range of the vocal is where the singer's voice is most prominent, and it goes from the bass to the baritone, the tenor, and right up here we have the generic. Let's play the vocal, observe which range it covers, and then set that up.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar from January to December.
As you can see, guys, this particular vocal lives somewhere here in the bass. Now what this does is it limits the detection algorithm in the plugin. So our plugin focuses only on the range of the vocal, which in this case is the bass, and ignores everything else happening outside this range. Now we've set our key, scale, and our range. We're going to leave this bottom section for now and we'll come back to it later. The next control I always reach out for, which is actually what sets this plugin in motion, is the note transition over here at the top. Remember how I told you guys in the beginning of the video that we are going to use the analogy of a compressor with the belief that you already understand how a compressor works? We are going to use that same information to help you understand how this plugin works. So, think of this note transition as a threshold in a compressor. Yes guys, you understand how compression doesn't work unless you've set your threshold to a right level where it starts engaging with the signal? The note transition also works the same way and it functions in milliseconds. On default, the note transition is always at 120 milliseconds. At this level, it's definitely already engaging with the vocal. But what we are going to do is we are going to turn the note transition to its lowest until it starts engaging with the vocal completely, and then we back it off gradually. The same way you would increase the threshold in a compressor to a level where it's completely crushing the vocal, and then you back it off gradually to its sweet spot. Let's do that, guys.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar.
And I would encourage you guys to listen to how the vocal sounds with every millisecond change on the note transition.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar from January to December. I need you on my antenna. My antenna. I know that I can do better. I know that I can do better. That's why I never.
Guys, on its lowest, it's at 0.1 milliseconds. At this level, the vocal is completely drowned into it. But then we are getting this undesired robotic effect. That's the reason why we want to back it off gradually till we eventually get to a sweet spot where the robotic effect is gone and we have some sort of a smooth tuning going on.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar from January to December. I need you on my antenna. My antenna. I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar.
Guys, let's just leave it here at 7.8 milliseconds. We are going to play with other controls and come back to it eventually. After the note transition, I always head straight to the speed control, and we are still going to use the analogy of a compressor. Guys, think of the speed control in the Waves Tune real time as the attack on a compressor. Yes, the speed control on your Waves Tune real time is equivalent to the attack on your compressor. The same way your attack determines how fast your compressor engages with the vocal is the same way the speed control on the Waves Tune real time defines the correction speed on your vocals in milliseconds. So basically what it does is, guys, it determines how fast the Waves Tune real time corrects sustained notes that are drifting out of tune. And just like the note transition, faster values on a speed results in faster corrections, and longer values let the Waves Tune real time take longer to correct to the target note. You see, guys, so let's set that up and hear how it sounds.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar from January to December. I need you on my antenna. My antenna. I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar from January to December. I need you on my antenna. My antenna.
Guys, let's leave it here at just 6.2 milliseconds, and just like the note transition, we are still coming back to it to fine-tune it more. So guys, after setting up the note transition, which we considered our threshold, and the speed, which we considered our attack, the next thing I always do is I engage this link control. So what this link control does, guys, is very simple. It basically links the speed control and the note transition control together. This gives you much more fine-tuning with the plugin, as you can now change both the speed and the note transition controls together.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar.
And whenever you feel that you want to change these controls independently, you just go right ahead and unlink, and you can now change the speed independently from the note transition. The next thing I always do after the note transition and the speed is I go straight to this tolerance control. These tolerance controls are a bit tricky, but I'm going to simplify it to you guys. The tolerance is actually two controls, the sense and the time. You can use this tolerance control to give the plugin a certain window of inactivity where it lets sounds you don't want corrected to pass through before correction starts happening. Now let me explain to you how this works. Let's start with the cents. The difference between one note to another is 100 cents. I'll take it over again, guys. The difference between one note to another on a chromatic scale is 100 cents. I hope you got that. Now, the way the WaveTune algorithm works on default is correction kicks in at a 50 cents threshold, which means after every 50 cents on any note that doesn't belong to the scale you've set, the plugin's algorithm corrects the note to the closest one above or below it. Now, this is the most important part, guys. You can use this tolerance control to fine-tune the plugin to sort of delay when this correction happens. Here is how you can do that with the cents control. If you set the cents to 10, which is 10 cents, and you leave the time off, this gives the plugin an extra 10 cents of inactivity after the default 50 cents before it gets into action, thus giving the note transition some sort of extra tolerance, hence the name tolerance. So instead of correction to start happening at the 50 cents threshold mark, it instead starts happening at 60 cents. You've given it extra 10 cents of tolerance. So if you increase to 20 cents, it means you have given it an extra 20 cents of tolerance. Instead of the correction to start happening at the 50 cents threshold, it starts happening at 70. If you increase to 30, it starts happening at 80 cents. So with this, you can actually delay when correction starts happening by either 10 more cents, 20 cents, or 30 cents. And we can push it right up to 40 cents, guys. You see, I hope with this you've understood how the cents work once and for all. Let's leave it off and talk about the time control. So guys, as the cent control works on a matter of cents, the time control works on a matter of milliseconds. The highest is 300 milliseconds. You see guys, how the time control works is this. If you set the time control at 100 milliseconds and leave the cents off, what happens is the note transition would only kick in after 100 milliseconds when the note must have passed the plus 50 or minus 50 cent threshold. This, just like the cents, is giving the plugin's algorithm some more tolerance, but instead of the tolerance being in cents, now it's in milliseconds. So with this, it means you've given the plugin's tuning algorithm extra 100 milliseconds of inactivity before correction starts happening. You see guys, we are going to leave it off, but then there are special cases where you use these controls, and just from the explanation I've given, I believe you know when to use and when not to use. Actually, on the plugin manual, it says, generally, tolerance prevents correction to a different target from the previously detected note, either by increasing the range from the previously detected note or waiting the desired amount of time outside the stipulated range. Let me break that down. If the plugin's algorithm has already detected a note above or below the 50 cents threshold and it wants to correct it, you can use this tolerance control to prevent correction from happening to that previously detected note and send it to a different target. Or you can give the plugin's algorithm a certain desired amount of waiting time outside the stipulated range. So we are basically talking about the cents and the time control at the same time. With the cents control, the tolerance delays correction from the target note only when the previously detected note differs by at least 60 cents. And with the time control, the correction waits a certain amount of time outside the stipulated range. So we can give it 100 milliseconds of wait time, or we can give it 200 milliseconds of wait time. So basically that is how tolerance works. So now guys, you understand note transition, speed and tolerance. We are still here on this page. The next control I always engage is the vibrato control. On default, the vibrato is off, which means the natural vibrato the vocal has is left unchanged and untouched. Now, in a scenario where you feel the need to add more vibrato to your voice, or you want to reduce the amount of vibrato that is actually present in a voice, you turn it on and you can reduce on a percentage level. You can reduce or you can increase, but in this case we are just going to leave it off and just maintain the natural vibrato the voice came with. So after that guys, we have our correction meters. Here we have the input meter and the output meter, and this rotary knob that lets us know how much correction is happening. When it's moving towards the right, it means the notes are being corrected to the closest note above, And when it's moving towards the left, it means the notes are being corrected to the closest note below. You see, an example could be correcting from C sharp to D or from C sharp to C. So if it's correcting from C sharp to D, you'll get the movement towards the positive side. And if it's correcting from C sharp to C, you'll get the movement towards the negative side, the left side of the rotary knob. So let's just play the vocal, you observe the movement and you get more insight into what the plugin is doing.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar.
I believe that was easy to grasp. So after that, guys, we have this correction control, and this correction control by default is set to 100%. Now we are still going to use the analogy of a compressor. Consider this correction control to be the mix knob in a compressor, where at 100% it means we are getting 100% out of the plugin, and anything less than 100% is already what you would refer to as parallel compression. Maybe we call this parallel correction, but then you get the point. So let's play the sound, change the figures and hear the difference.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar.
And as you can also see, guys, when we reduce the correction percentage, the level of movement on the rotary knob actually reduces. If we actually switch it off, then no correction is happening.
I know that I can do better. I know that I can do better. That's why.
Remember, this is different from actually bypassing the plugin completely. We have just bypassed the correction effect, but then the plugin is still on.
I know that I can do better. I know that I can do better. That's why.
When we switch it on, we have correction happening.
I know that I can do better. I know that I can do better.
But in this case, correction is just happening at 50%. And as you can see, that is why the movement on the rotary knobs here is limited to just the top. I always leave it at 100%, guys. I would advise you do same. After that, we have the format control. How this format control works is, on default is corrected. When it's corrected, it actually preserves the natural timbre of the voice. Yes, by preserving the natural timbre of the voice, it helps you avoid this chipmunk effect when correcting to higher pitches and higher octaves. But we are going to leave it at corrected, guys, because that is how we want it on these vocals, and you should always leave it at corrected, except you want to achieve that chipmunk effect. I believe we are done with the top section of this plugin. Now let's go back to the bottom again. So guys, we're going to go back to the scale, and I'm going to show you something about this plugin that really makes it stand out and makes it so user-friendly. You remember how I told you guys in the beginning of the video how I like the key and the scale of this song being C major, and that tells us we are dealing with on the white notes. This is where that information comes in handy. Let me show you guys something. If you notice on this keyboard, you'd actually see that every black note, because it doesn't belong to the scale of this song, has this pink square thing going on above it. Every black note, because it doesn't belong to the scale of this song, has this pink square thing going on above it, right? This lets us know that these notes do not belong to the scale of this song. But then, guys, with modern music, you would often hear every now and then where a singer will hit a certain note that doesn't belong to the scale of the song. But for some reason, it still sounds okay and it sounds pleasing. How do we set that up with the WaveTune real time to not correct those notes that are out of scale to the closest note below or above it? Let me show you. So, if you right click on any black note that is not part of the scale, for example, let's right click on C sharp, we see something going on here. We quickly notice that the reason there's nothing going on above this C note and every other white note is because these are legal notes. Legal means these notes belong to the scale of the song, so they are legal. And these other notes, like the C sharp, do not belong to the scale, so they are illegal. That is why every black note has this illegal sign on it. You see? Illegal. But then, let's say hypothetically in a scenario where our singer keeps hitting C sharp and we want the WaveTune real time to ignore that C sharp, it shouldn't correct it to the closest legal note, be it D or C. What we do is we can right click and we can select bypass correction. What happens is, you see, now every C sharp has this X above it. It means our plugin is going to ignore C sharp when correcting. So whenever the singer hits C sharp, it's going to leave it untouched. It wouldn't correct it to the closest note, could be D or C. You see, guys?
I know that I can do better. I know that I can do better. That's why I never say never.
That is just the beginning. You'll also notice that because we bypass correction on C sharp here on the second octave, every other C sharp has been bypassed. You see, which is a good thing. But then there are scenarios where you'd only need the C sharp on the second octave to be bypassed. What do? You come down here to the group octaves control, right down here, guys, and you switch it off. Now when it's switched off, you have the ability to select on the C sharp on the second octave to be bypassed. Every other C sharp remains illegal, you see, guys. So we are going to put our C sharp back to illegal, and I'm going to show you some more things happening when you right click. So guys, imagine another scenario where, let's say your singer is fatigued, he's tired, and whenever your singer tries to hit D, because D is the right note in the scale, they always end up hitting C sharp, they don't hit D. And because of that, our plugin recognizes that C sharp is not in the scale of this song. So it naturally corrects the C sharp to the closest note in the scale. The closest note could be D or C. It depends on the level at which the singer hit the C sharp. If the singer hit the C sharp by 40 cents, it's going to correct it to the closest note, which is down, to C. But if the singer hit the C sharp by 60 or 70 cents, it's going to correct it up to the closest note above, which is D. Now, if the singer keeps hitting C sharp whenever they want to hit D, and the plugin cannot tell if they wanted to hit C or D, what happens is the plugin corrects it to the next closest note. And in a case where we wanted our singer to hit D, but the plugin keeps correcting the C sharp down to C, we can actually come here and set it to always correct up. You see, illegal correct up. So whenever our singer hits C sharp, our plugin corrects it up to D instead of down to C. Now, we could also find ourselves in a scenario where we want our plugin to correct the C sharp down to C instead of up to D. So we said illegal correct down. So whenever our singer hits C sharp, our plugin corrects it down to C. Let's set it back to illegal, but then you already understand how this works, guys. There's this last thing I haven't mentioned. There's something important going on here, guys. Stay with me. When you select this, you will have the ability to choose between different scales. So it's not just the major and the minor scale. There are different scales, and this will come in very handy, especially with modern music, where you think you've set the key and the scale right, but for some reason, something keeps sounding off somewhere along the line. It could be that you're actually not on a major or minor scale. You could be on a major Justonic, minor whatever, Dorian, you see, Mixolydian, and all these other scales. So in case you're not satisfied with the scale you've set and you believe that the singer's performance was right, you want to play around with these different scales, something might work out differently and turn out better than your natural major or minor scale, you can also set a user scale. When you select this user scale, every note becomes illegal. You can go in and manually select one note after the other and make it legal. You can create your own scale and make it work with the plugin. You see, guys, so the plugin is not limited. You can actually set your own user scale and make it work. When I was working on this vocal, I also noticed that there's this scale that sounded much more better to me than the major scale. And that was the, that was the Mixolydian scale. I found that this Mixolydian scale worked better with this vocal than the major scale. Let's play it and hear how it sounds.
I know that I can do better. I know that I can do better. That's why I never say never. And I got it on my radar. I've been looking for my cheddar. From January to December. I need you on my antenna. My antenna.
So guys, now that you already understand how this works, let's come here to the MIDI input/keyboard. So these controls actually work with a MIDI controller or a keyboard, but you can also use it without it. How the reference tone works is, if you find yourself in a scenario where you're forgetting how a certain note sounds like, or where you want to tell your singer in the box, let's say they want to hit C, but they keep hitting D or they keep hitting B, You can select the reference tone here and with a mouse actually click on the particular note you want them to hear. So this is C, this is C, this is D. You see guys, this is a very handy tool. I'll be honest with you guys, I've never used the target pitch before, but I understand it works like this. You remember the name Waves Tune Real Time, which means it actually works in real time. Let's say you have a scenario where the singer keeps hitting E instead of F, you see. You can actually work together with the singer, and whenever they reach that note and they hit E, you manually select F at the same time. So when you do that, the plugin automatically recognizes their E as F and corrects it in real time. Very useful. And then after that, I think the last thing we haven't touched here is... So what the reference tone does is, it's basically for tuning. Let's say you're tuning your instrument, a guitar, and you need a reference tone. So yes guys, thank you for staying with me right to the end of this video. Thank you for watching. I hope you learned something from this video, and it's really my wish that this is the last video you're going to need on the Waves Tune Real Time plugin. Guys, please hit the like button, drop a comment, and don't forget to subscribe. It's going to go a long way to help the channel. And I guarantee to give you more in-depth breakdown videos simplifying these plugins. Thanks for watching, take care, see you in the next video. Ciao.